For us to have 330 kV panel, we have 330 kV switchgear, and we have 150 kV switchgear. And I told you that in between the two switchgear, what is in between? The transformer.
The transformer.
You understand? Look at our transformer, all these lines. Those are our transformer. Or everything you see here. This one transformer, this another one. That's another one. So those that are there, you might not see very well. You have 1, 2, 3, 4, 5, 6. Can you see? Yes, sir. 6 transformers. This one is not a transformer. This is a reactor.
A reactor.
What do you reactor do?
Reduce voltage.
To step down or suppress voltage.
Suppress voltage, yes.
Voltage is high. That is what we do. You know, our voltage is low now. That's why we need to switch. If we put on hear the sound, you know, you are hearing the sound of the transformer. That's why you didn't hear any sound. So this is the reactor. You understand? So we have 5 at 1, 2, 4, 5, 6. Have you? Can you see 6? But that the 6th one is that was when you have what do you call it? What do you call it? When you have that container, thank you. That's but at the other side of that 6th one, you have another reactor. You cannot see because there is a wall like this. No, there is a wall. And that's why you cannot see. At the other end, so these are transformer. You know, the transformer is standing between 330 and 132. Yes. That switchyard there is 330 kV switchyard. Can you see it? Yes. This switchyard here is 132 kV switchyard. Can you see? Then if you look at transformer, that side of transformer should be what?
Primary side.
Primary side. And if you look at, you see the terminal that is standing. You see that it is bigger at that side because it's voltage. Look at this side. Look at the smaller. So it means 132 is smaller because smaller voltage is coming out from here. Do you understand? So that is switcher. Then all these things you see inside, they are the switches. That's why they call this place Switchyard.
Switchyard.
You understand? Switches like the breaker that I showed you inside that panel.
Yes.
Those breaker, those things that the panel I showed you is for us to control this thing remotely. Do you understand? It is not good for us to go there, turn it on or turn it off. It is very dangerous. But if you go there to turn it on, it might shatter as you are doing that. And that person that is there is not the one that will tell the story. So that is why it is not good for us to go and operate them locally. We call that locally, you understand? That's why we operate them remotely from there. What is here? If they open a breaker and you hear bam, but they are not opening anything now. But before we leave there, if you hear any sound, bam, it means they've operated one. Because it means the contacts. You understand? So they call it switchyard. All these breakers, they are just like the switches you use in the house. When you enter your room, what will you do to get light? You switch on you understand? But what we use here, our switch here, we call them breaker. You understand? Another one is isolator. Do you understand? We have those two. Isolator. Good afternoon. Yes. So we call them isolators and breakers. Those are the switches we have. You understand? There is a way, they don't just, you see, no, you see them, you are looking at them. There's an arrangement for them. There's a way they arrange them. They don't just come and put one here. There is an arrangement. If you get to, are you doing power?
Yes, sir.
If you are doing power, you are power student. Yes, go and read about bus bar arrangements. Go and read it. They have single bus bar arrangement. They have double bus bar arrangement. You know, I showed you two buses. So we operate two bus bar arrangements here. Even under these two bus bar arrangements, we have different types of double bus bar arrangements. We have one that's called main and reserve bus arrangement. But our own here, they call it 3.5 cycle breaker. 1.5 cycle breaker system arrangement. 1.5 cycle breaker system. It means for one equipment. Okay, it means, what can I say now? There is, when I was there, you didn't ask some questions. There are some questions you will have asked me about those panels. You understand? Those panels, there's a what we call a diameter. Look at here. Look at this straight line. That's a diameter. That's even when you get to the control room, it's a single line like that. But that single line, you will now have all those knobs. All those knobs that have lights, you understand? You will see the knob for breaker and the knob for isolator. This is a single diameter. We have this diameter now, it has 3 circle breaker. Do you understand? 3 circle breaker. And these 3 circle breaker, they are controlling 2 equipments. Do you understand what I'm saying? 2 circle breaker controlling, 3 circle breaker controlling 2 equipments. If 3 is controlling 2, that's 3 over what? 3 over 2. What is 3 over 2? 1.5. That's why we call it 1.5 circle breaker system arrangement box of double bus bar. Do you understand what I'm saying? So go and read it.
Sir, what type of circuit breaker? Type of circuit breaker?
Yes, we have different types of circuit breaker.
What are we
The one we use here, we call it SF6 gas circuit breaker.
SF6.
We call them
Sulfur
named
chloride.
by something they call arc quenching medium.
Yes.
You understand?
Yes.
You understand?
SF6.
SF6.
Sulfur chloride. Sulfur chloride.
Something, you know. SF, then 6
Sulfur
is a chemical, you know, like oxide. You know.
Sulfur
I forgot it. Go and I just have forgotten it. SF6. You understand? It's a chemical.
SF6.
So it's a gas. It's a gas. They call it arc quenching. You understand? There are breakers they call vacuum
circuit breaker.
Vacuum circuit breaker.
Yes.
You understand? There's some breaker they call air circuit breaker.
Oil circuit breaker.
There's some circuit they call oil circuit breaker. Do you understand? Those are the circuit breaker. Did you ask me why they call them that?
Yes, sir.
Those are the arc quenching.
Quenching medium.
Do you understand why I say arc quenching?
Yes.
Yes.
Eh? What do you understand by arc quenching?
This is suppress. We use below the fire. This is suppress.
No.
Clap for yourself slow. I give you like 60%. You see, we operate high voltage. When you get to your house and you switch on your light, your light will come up because it is small voltage that is there. But when it is coming to very high voltage, if you want to separate two something that are contact, it will give spark. You understand? And the spark is very high. In fact, if it is in the night, you will see it as a very bright light. Yes?
Why are you talking to them? Not all of them are covering their heads. Oh, that was Switchyard.
Yeah, what Switchyard? No, we are not entering Switchyard. That is.
Oh, that means you can find one.
You can find them.
How much?
2
million. Okay, now.
So now, if you want to open a circuit breaker, if you open it, you understand? If you assuming circuit breaker, if you open it, there will be a serious fire. But then what they now did, those that made circuit breaker, is that the contact of circuit breaker, you understand? They embedded it inside something. You understand? Inside something. Then when they embedded inside that is they put them inside something, you understand? So when they separate, they will cause fire. They now put something inside that where they embedded them, so that when there is fire, that thing will quench that fire. So that fire is what we call arc. It's not really fire, it's arc. It's arcing. You understand? Yes. So to quench that arc, to make that arc not to be, that is the arc, that is the medium. This one that you are looking at is a breaker that has T shape.
Yes.
It's a breaker.
Wow.
You understand? The contact is inside. You cannot see it. Then inside that breaker also, they put what we call the gas that is called SF6 gas. You understand? So that when we open that breaker and the contact, they separate like this. Instead of giving fire, it will not give fire. because that exercise gas is already there. It will quench it. The fire will not even occur at all. Do you understand? Because if fire occur, it's explosion. So all those some breakers, some 30 kV breakers, they embed those contacts inside oil. Oil. Inside oil. We don't have them here. Even they are facing out inside oil. So that's why you call it oil circuit breaker. Some of them they embedded them inside a vacuum. Inside a place. They now extract the air away from it. And you know that when there is no air, what will happen? There won't be what? There won't be fire. Is it no? That's what they call it vacuum. You understand? Some they embed them in hair, special kind of hair that cannot allow combustion. Do you understand? So that is it.
About the transformer, is there a silicon gel?
Yes, we have silicon gel. This one that you see now, see those 4 something coming down.
Yes, sir.
4 rows coming down.
Yes.
You can see 2 of them, they are carrying some things under. The two in the middle, they are carrying something under.
Yes.
Inside those things, they will have silica gel to extract moisture. You understand?
He said if you come out and show us
Reactor. That's this reactor. This is reactor. So you my voice is not like that's why you move here.
You want to see everything.
Okay, you want to see everything. Okay, but those at the back you are hearing.
Yes, sir.
Okay, somebody asked one question. Who asked that question? That how do we detect faults on the transmission line? It's a very, very important question. You understand? Because it will make me to mention 2 other things or 3 other things that are very, very important in the station. If you don't ask it, I cannot tell you. You understand? Here, we have inside here, you understand, apart from isolator and circuit breaker, inside the switchyard, reactors are here. But inside that place, we have 2 instrument transformer also. Who knows what they call instrument transformer? What are the instrument transformer? Instruments. If you are around 400 level or HND2, you should know. Instrument transformer. What do they call instrument transformer? Okay, apart from this power transformer, what other types of transformer do we have? Distribution is still power transformer. We can call this our own transformer, transmission transformer. What they use in distribution transformer. Why? Because our own transformer is far, far bigger than their own transformer. You understand? This transformer alone can buy how many of their own. You understand? These are very costly transformers. You understand? That is that. But we have voltage transformer and what? I'm giving you one. There are 2. Voltage transformer and which transformer again? Current transformers. We have voltage transformers, we have current transformers. What is the job of these 2 transformers? Who can tell me? Who can tell me? Somebody will have asked me, how do we even read all this voltage inside our meter? Is it the conductor that we pass inside? Can we pass conductor inside?
No.
To read the voltage in the conductor? And then is there any meter that will put the conductor to be able to know face by face what is the voltage? Then you should think. No, not communication. We call it control cable. The cable you are talking about, no, I have not got into cable. We use control cable here. You understand? Then, voltage transformer is the transformer that steps down our voltage to the minimum that we can, that is not injurious, that we can use with our meter. You understand? To be able to, for metering. You understand? They help us to step down our voltage for metering. Then current transformer also. They help us to do what? To step down the current that is flowing. For what again? For metering. Do you understand? That's why we can tell you the voltage that I told you to look back. You saw the voltage, Abi? It is because of the voltage transformers. You understand? The voltage transformer now step down that voltage to a very small voltage. Then they will now use calibration. Have they taught you calibration in school? You understand? They now calibrate that voltage, that small voltage, so that we can be able to know if it is 330, if it is not up to 330, maybe it is 320. You understand? In that meter. Do you understand? Yes. The same thing. Current transformer, step down the current to the barest minimum, and then they now when it's bring it down to barest minimum. That minimum you can use ordinary control cable, all this small cable. Now, just bring it out to maybe the highest ampere, or that can flow. It will bring it down to 1 ampere. That 1 ampere you now calibrate it. It means that 1 ampere will not be the highest current. So the remaining, you understand? That's calibration, which is not harmful, which you can use a cable to pass inside. And then this meter can work with, you understand? And you calibrate it. You understand all those ones now? They are instrument transfer. You should know them. Which level are you? Saying no. Because what the person asks me is, how do we detect if there is fault? So I'm coming gradually to that. If I don't explain all this thing to you, you will not know. You understand?
All right.
I've told you what current transformer and voltage transformer they do. But current transformer is also used together with what we call relays to detect if there is fault in our system. It cannot be detected by just is an automation, because you cannot know if there is if there is a fault in the system and there is no automation to remove faulty part immediately. Explosion. In fact, as we are standing, you will have been hearing proper boom, 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 explosion. But there is something we call protection scheme that has been embedded in our system. Do you understand? Relay, current transformer, and then there is another thing I said that then DC. We have DC here, DC voltage. We have DC room. So all those relay, they work with this. They don't work with a normal. They work with DC, direct current, 110 volts. Do you understand? That is what they work with. Do you understand? 110 volts. That is what, see, all these kiosks, it's our relay that are there. This relay now, if you look at Alimosho line 2 times, Alimosho line 1, this relay, that is what it is connected to. So what they do is this. If there is any fault on the line, for example, this Alimosho line, a vehicle collides with the pole, you understand? And the thing twists, you understand? The thing will generate fault current. The current that will be flowing will be far more than normal current. Do you understand? Then when that current will be flowing back. So when that current is flowing either here or to Alimosho, as you see, this thing here is at Alimosho 2. We have at Alimosho end, there is also relay there, everything. It will be flowing towards any direction that it can flow to. If it gets here first, that fault current, you understand? This current transformer, we see it. Current transformer, we see there is a danger. Yes. You understand? Yeah. We see that there is a danger. It will calculate that something. You understand that this is a danger. That current transformer that is seen, not current transformer. The current transformer now will send the current to the relay. Okay. The relay is seeing what current transformer is measuring. And because the relay has been set, they set the relay. There's a department, we call it PCMA. They set the relay. You understand? The relay now, when it now see that, there's a problem here, that relay will now send a signal to the breaker that is controlling that line. And that breaker will do a trip and remove it from the system. If it doesn't remove it, that fault current will go into every line is connected to the bus. It will go to the box and go affect everything and collapse the whole station. But for the station, and even cause it can even cause a fire outbreak. You understand? But for that not to happen, that is this protection scheme that has been set. It is there. Every line and every equipment here has its own protection. Do you understand? And this is that I'm telling you, if there is a fault, it doesn't take 1 minute to, you know how electrons work. Split split second, it will remove it fast. Because if you say a man should do that, what will happen? This place will burn now. Do you understand? So that's why there is an automation that has been set in our system to help us. Do you understand? Do you understand it now? And they work together. Delays, that's why we have delay. And any fault that occur, delay will tell us. Even delay will tell us the distance. Yes.
At the control room now.
Yes, it will tell us. When there is any tripping now, we just come. If it is this emotional one, we come to this emotional one. The relay is there. The relay is a digital relay. It has a screen. The screen will tell us it's overcalling fault. Or if it is not, if it is head fault, it tells us it's head fault. And it tells us the distance. Maybe it is 2 kilometers. Any kilometer it will tell us. So that the lines people that are maintaining the line, they will now, if it tells them 2 kilometers, they will go to that, around that. You know, it's electronics. It cannot tell you the exact. But it will tell you then it has told them the boundary. The range of. So they will now go to that range. They will now tell you, okay, it is within this tower so and tower so. You understand? They will now go there to go and see what is actually happening. Maybe it's a bed that is there. Maybe it's maybe something flew in the air and go and touched. So what's wrong? Sure, you understand? So the person who asked the question. So you understand now?
Yes, sir. Yes, sir.
So that's it.
Thank you, sir.
The people that is coming from the transmission companies that is coming here before you send it out for that generation. Like, can you show us?
The cable.
Yes, all those ones.
Oh, see now. All the 330, see them.
That is coming here.
Yeah, coming here. Those are the 330 kV lines now. Can you see all those towers?
Yes,
They are doing the lines. Can you see the lines there? Yes. You can see that this conductor, they are double. Yes. Can you see them? Yes. Anywhere you are going outside, you are traveling, you see a tower, very high, and you see each face, double conductor. That's a 330 kV.
So what are the size of the cables?
Size
of the cables.
This size, it can be 350. These are our own. Most of them are 350 mm. 350 mm. For this 132, most of them are 250 mm. Then if you look here also. Look here. Can you see other towers? Can you see other towers?
Yes, sir.
Just for one conductor.
Down is going down.
That and it's going. It's not this for 132. It's going out to almost Animation over the 132 Ogba, and they are one. So anywhere you see tall tower like this, very tall, and it's only one conductor. That is 132. And you know that towers like this belong to us. This code, their own is always short. Sometimes they use concrete. Most of them they use concrete. So that one will always be better. It is for insulation. You understand? It's for insulation. Move there so that you can other people. Move back. So that's another good question. He's talking about earthing. Earthing should be superb here. Our earthing here is superb.
Superb.
Very superb. Yeah, we have somewhere that our earthing is buried. Serious earthing system. You understand? And then from there they now all this gantry, all these things that you see here. Yeah. If you see that move you close to them, you see that there is a copper conductor that comes from down and they knot it to them. That is coming from our earth, from the center, the earth or something. So everything is connected to the earth. Do you understand? Everything is connected to the earth. Let me see. Look at it. Just like
Yes, sir.
That is this one is also earth. So that is how all the structures they are earth.
You gonna call my star? Who be you?
So all this, even this way where I'm standing with my excavating, you might see earthen conductor, copper conductor going round. You understand? But this place goes seriously. We operate very high voltage. Very high voltage. Even though everywhere is earthen, when there is rainfall, you are advised not to go out. You are advised not to go inside. Do you understand? So that is it. Any other question? We use cooling system. Yes, we use. Is it for transformer? Yes, yes. As in, we are here the transformer home. That sound, you know, we call it on and on off or something like that. Oil, air. We use oil, we use air, we use fan. This transformer, you see what is under it? You see that round something under it?
Yes.
Okay, you see that thing that is here? That is vein, cooling vein.
Okay.
You understand? Cooling vein. It is cooling down the transformer. You see the something under it? That is fan. The sound you are hearing, the part of the sound is fan or some other fan rolling to cool it. And then there is oil inside also that is going around the transformer to cool the transformer. So you can see how many something now? Air, oil, and fan.
Or double.
You understand?
Yes, sir.
So, and they are all automated. You understand? Sometimes you see the fan, it will not work. It means it has not, the temperature of the transformer is not yet up to when it will cut off. Not cut, I mean cutting. You understand?
Thank you, sir.
Thanks. Hello?
There is one point.
Okay, oh, the madam is oh, there are no problem. So, I think
pé ṣe fún mi ọjọ́ mẹ́ta ló máa lò tó fún ọjọ́ mẹ́ta.
yes, there is not enough. You understand? We have aged equipment. There are a lot of problems. You understand? From the generation side to the transmission side to the disco. Sometimes they will tell you it's transmission that has problem. If you see the person who will tell you it's transmission that has problem, it should be a disco man. You understand? If they say there is a problem in the disco, if you look at that person will not be a disco person. It will be transmission or generation. So, do you understand? We are just pushing it. But if you want me to be sincere with you, every sector has its own problem.
Yeah, definitely.
Do you understand what I'm saying now? Every problem. Throughout the old power something, we have old equipment. Old. Very aged equipment or aged whatsoever you want to call it. There are many of these things, they started this station. I'm old now, that I told you. There are many of these things you see, they started this station with them. You understand? And we are still using them. And they are still operating.
Why is that?
But you should know that they were still operating, but we are managing them.
Yes, maintenance.
How do you manage when there is grid collapse?
How do we
Manage when there is grid collapse?
manage what?
Like manage the system when there is grid collapse.
If there's grid collapse, nothing to manage again. The only thing that we do, we have a generator, then we just switch on our generator and begin to wait for them to restore us. You understand? Or maybe if any of you, maybe tomorrow you have a generating station, you say you want to collect, you come here, this man, you still there? Okay, if I'm still here, okay, I want to supply you, I have a generating station now. Go to my guy, you go and sign agreement first. So you sign agreement, they will allow you. You understand? Okay, you're welcome. So I just please, I just want to, as a final note,
Yes, sir.
what they are teaching you in school, please be attentive to it.
Yes, sir.
Do you understand?
Yes, sir.
Be attentive to it. I told you that I did communication, but when I was in 400 level, I graduated from LAUTECH, 1998.
Wow.
You understand?
I was not born then.
You are not born there. So when we are in 400 level, they taught us part of, they call it rural electrification. Do you understand? Thank God that they taught me then. You understand? When I came here, though I did communication, I have to key into what I meant here. Do you understand? And I saw that those some things we learned in theory, but you can bring them here to practical. Do you understand what I'm saying? Yes. So that's why I say some things you are learning, please be serious with them. You might not know where you meet yourself. I read communication, but today I met myself in power. Initially, I wanted to leave. When Globalcom started, I wanted to leave. But where I am today, at least I'm 20-something years in service.
Wow.
I'm still there.
That's awesome. That's for celebration, sir.
Okay, I'm engineer Alaba Adewale.
Ó tún gbé mi débẹ̀.
So God bless all.
Thank you, sir. Thank you, sir.
I love you all.
We are possible.